Hello, we are students from Hong Kong Polytechnic University.
I'm Crystal.
And I'm Liz.
Liz, what are we going to do today?
Do you know how to make a pencil stand on a table?
I have no ideas.
But I know one experiment called standing pencil that we can easily do at home.
Really?
Yes, shall we look at what materials do we need for the experiment?
Sure.
Let's go.
Let's go.
To do this experiment, we need the following materials. First, the iron wire, pencil, and the objects that contain some weight, such as tape and other materials that you can think of, such as brush and the key rings. All the materials can be bought in the local stationery store in Hong Kong. As we have to twist the wire, we also recommend you to get a plier. So now all the materials are ready. Let's get started.
So now we can start the experiment. Take out the iron wire. The first step is to wrap one end of the iron wire around the pencil. Here is the tip. The position of the wire wrapped around the pencil is very important. The closer you are to the tip of the pencil, the straighter and more stable you will stand.
After wrapping the wire, we can go straight to the second step. Hang the object that you choose to on the other end of the wire. The material that we choose is the tape. Here comes the second tip. It is best to press the wire out of an arc and bend it directly under the pen tip so that you can stand up straight. If you want the pen to stand properly, just pull the wire to adjust the position of the object's weight below the pen tip.
Okay, let's play a magic. 3, 2, 1. Ta-da! Yeah, the pencil is standing in balance at the edge of the table. Attention here. The balance relies on supporting the center of gravity, keeping the pencil standing. If you tilt the pencil slightly, it can always restore balance easily. You can also change the center of gravity to make more interesting movements. As long as you adjust the position of the object, the pencil can lie almost flat, and lie flat on the edge of the table with the tip of the pencil. Then, let me show you the phenomenon. The reason the pencil stands is because it has a low center of gravity. The lower the center of gravity is, the more balanced it is. Use the weight of the hanging object to move the center of gravity of the pencil directly under the tip to lift the pencil upright. The position of the wear must be close to the nib, so that the center of gravity can be easily adjusted below the pencil. In this way, the pencil will be easy to stand upright. If the wear is far from the nib, the center of gravity cannot be adjusted below the nib, and the pencil will be easy to score. The center of gravity of a body is the point at which the resultant force on the body is zero. The torque guaranteed by the resultant force at a point of action is equal to the sum of the torques guaranteed at all points of the body. Then, the point of action is the center of gravity of the body. The theory is to say, the center of gravity is not only the point where the weight of the object is concentrated, but also the equilibrium point of the moment guaranteed by all the particles of the object. Therefore, as long as the force is applied to the center of gravity and the combined moment of the force applied and the weight of the object is zero, the object cannot move and present a state of equilibrium. There are various applications of center of gravity in our life. In this picture, there is an exciting acrobatic performance called whale walking. By adjusting the body posture and the position of the held steel tube, the acrobat makes the force applied to the center of gravity of himself and steel tube, and the combined moment of the force applied and the weight of them be zero, to keep the balance in the performance. Okay, then let's try to learn some methods to find the center of gravity of some simple objects. The center of gravity of the triangle is the intersection of the three sides, and the center of gravity of the line segment is the midpoint of the line segment. And then, the center of gravity of a parallelogram is the intersection of its two diagonals, and the intersection of the midpoints of the two pairs of opposite sides. And the center of gravity of a circle is the center of the circle, and the center of gravity of the ball is the center of the sphere. Okay, let's continue. The center of gravity of the cone is the one closest to the bottom on the quadrant connecting the top and bottom of the center of gravity. And the center of gravity of the tetrahedron is the intersection of two diagonals. The center of gravity of the cylinder is the center of the middle section of the cylinder. And finally, to find the combined center of gravity, we should first find the center of gravity of each object, and then determine the center of gravity of the combined body.
Since today we are talking about gravity, we have also prepared another small experiment that is related to gravity in order to further explain the theory. It is called the bamboo segment. First, take out 3 bamboo stakes. Cross their heads and tie them tightly with a rubber band. After the first step, take out one bamboo stick and place it horizontally on the bottom half of the other 3 bamboo sticks. Then, tie them tightly with 3 rubber bands one by one. For the last step, put some blue tack or paper clay on the bottom of the 2 bamboo sticks, which are the 2 placed on the left and right. Be careful, the weight of the blue tack of 2 sides should be the same. Then the bamboo stickman is completed. Now we can try to place the bamboo stickman on a finger and see if it stands. As you can see here, it may fall down easily. So obviously adjustment is needed.
Scientific knowledge is closely related to everything in our daily life. The knowledge learned in scientific experiments can make us have a better understanding of the phenomenon around us and use scientific knowledge to solve problems in our daily life. Wish that all of you can make the scientific knowledge in this experiment your own.